long, long time ago, in a land very far distant from here, there lived a farmer who grew fruit trees and strawberries. And one day he decided to set up a little experiment. He had a problem. And he gathered some fruit and berries together and other equipment that he had. And what he had was two scales, this one on the left and this one on the right. And for this little thought experiment, he gathered together, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 strawberries, 4 apricots. And since it was a long, long time ago, he didn't have electronic scales to accurately measure things, right? But he did have those two scales, and he had an 8-ounce weight and a 10-ounce weight. And then finally he had some brakes for his scales that you can use to hold these plates up whenever you add things to the plate, so that you don't damage the scale. Now he had two goals that he had set for himself, and the first one of these was to determine the weight of the strawberries and the apricots so he could price them correctly. And while he was doing this physically, moving strawberries, weighing strawberries, and putting weights on, he also wanted to see if he could describe his actions with the scales with equations. So here's how he started. He had it set up like this, and he didn't know exactly what to do. All he knew was that he needed to do something, had to start. And it's good like that in math. Sometimes you just don't know. So you just try something to see if it works. So the first thing he tried, after damaging his scales, hopefully the strawberries didn't weigh too much and damage the scale. So he put the brakes up here, and he loaded this tray with 3 strawberries and 2 apricots. Then it was time to add one of these weights. He didn't know which one to add, so he just tried one, and he put the 8-ounce weight on that tray. And then he moved the brakes away to see what would happen. And he was really, really lucky, right? It worked out really well for him that those 3 strawberries and the 2 apricots balanced exactly with the 8 ounces. At this point, he said, well, maybe I can go ahead and write my first equation. And so he said 3 strawberries, I'll represent that as 3s for strawberries and 2 apricots equals 8. He felt pretty confident with that equation. And he had some stuff left over, so he said, okay, let's put some strawberries on this tray. I've got 6 left. I'll put them here. So he added 6 strawberries. Yeah. He's not really good at using scales. Probably why he broke so many. And then he had some things left over, and so you don't really know what to do. So he just grabbed this 10-ounce weight and put it right there. And then when he took the brakes off, right, something a little different happened. His scale didn't break this time. His scale didn't balance this time. So this side of the scale was heavier than this side, but he still had some apricots to put on, and he figured, okay, if I add some apricots to the right-hand side, maybe that'll help out a little bit. So he took an apricot, put it on the tray right there, knowing that the apricots don't weigh very much. He didn't put the brakes up there again. And when he did that, something magical happened. The scale balanced. So now he determined, let's go ahead and rewrite those equations again. And so on the left-hand side, it's still 3 strawberries plus 2 apricots equals 8 ounces. And over here on this side, he has 6 strawberries equals 2 apricots plus 10 ounces. So he's got 2 equations, 2 unknowns. He's got 2 scales loaded up. And he remembers some place that he heard in math class long ago was that if you have 2 equations, right, 2 equations mean that the left-hand side of the equation equals the right-hand side of the equation. And we have that situation here. This side equals this side equals this side. And both of those situations are described by these equations. And he was wondering, looked kind of complicated right now, if he could simplify things a little bit. So he decided that he would just add the left side of this scale to the left side of this scale, and the right-hand side of this scale to this scale over here. And when he did that, he got something that looks like this. In this time when he wrote his equation, he had 9 strawberries and 2 apricots, and that equals 2 apricots plus 18 ounces. Now he looked at his scale and noticed that he had apricots on both sides of the scale. And he figured that he could just subtract, he could subtract those apricots from both sides and everything would still be balanced. And on the equations, if he subtracted 2 apricots from the left-hand side, right, that would mark this out, and 2 apricots from the right-hand side would mark that out. That left him with this situation right here. And writing the equation for that, he'd been being very studious about writing the equations to describe what's happening on the scales. He said, okay, I've got nine strawberries equals 18 ounces. And from algebra, from 8th grade math, he knew that this was a multiplication, and to undo that multiplication, he would divide by that 9, that coefficient, divide both sides. Whatever you do to one side of the equation, you have to do to both sides of the equations. In that case, these 9's cancel out. 9 divided by 9 is 1. And we know that 18 divided by 9 is 2. So at the end of that, he has that the strawberries weigh 2 ounces each. He was pretty happy with that. He had solved how much the strawberries weigh, and he had written equations for everything all the way through. He was kind of interested in maybe using just the equation, see if he couldn't get the same result. So originally he had this equation, 3 strawberries plus 2 apricots equals 8 ounces. And his second equation, when he loaded up the other scale, was 6 strawberries equals 2 apricots plus 10. And physically he moved strawberries and apricots and weights around and added the right-hand scale to the left-hand scale. And this equation was the left-hand scale. This was the right-hand scale. So what he wanted to do was represent what he did physically by these equations. And since he added the left-hand side, or since he added the right-hand side of the scales to the left-hand side, he thought he would just add the equations the same way. So he did this. Now he had 6 strawberries plus 3 strawberries, all the strawberries on one side. So he had 9 strawberries plus 2 apricots, and that equaled 2 apricots plus 18. Adding the 8 and the 10 together. Those are common terms. Those are number terms. We add those together. We can't add them directly to the 2a. But then he recalled what he did with the apricots, and he removed them from the scale. So removing is akin to subtraction, so he's going to subtract 2 apricots from the left-hand side of the scale. He's going to subtract 2 apricots from the right-hand side of the scale. And he got 9 strawberries equals 18 ounces. And doing the same sort of thing again, dividing each side by 9, dividing each side by 9. He came up with S equals 2. Just like he did physically. Visually he did that, and algebraically he did exactly the same thing. The whole point being that whatever you can do physically, adding things to the left-hand side, adding things to the right, moving whole things from one position to another, you can represent with equations. whenever we have two equations like this that we're working with at the same time, these are called systems of equations. And our goal with systems of equations, we're going to have two equations and two unknowns, is to finally work it down to where you have one equation and one unknown. And that's what we had here. After we subtracted the apricots from both sides, we're left with a single equation with a single unknown. At that point, he's not quite finished. He's not quite finished with the problem. He still needs to know what the weight of the apricots are. So he goes all the way back. Now he's feeling pretty good about his algebra. So he goes back to the original equation, which was 3 strawberries plus 2 apricots equals 8 ounces. And he knows that the weight of a strawberry equals 2. Now he's got two equations and two unknowns, and he's going to use the substitution method to solve this for alpha, for the apricots. So all he's going to do is take this equation here, this value of S, and he's going to substitute that into that top equation to see what he gets. So it's going to be 3, replace the S with the 2, bring down the 2 apricots, and that still equals 8 ounces. Things are looking pretty good for him. 3 times 2 is 6, if he remembers right, plus 2 alpha equals 8 ounces. And from 8th grade math, he recalls that he can eliminate this 6 by subtracting, but if he does it on this side, he also has to do it on this side. And when he does that, these 6's zero out. This is called the additive inverse. And you're left with 2a equals 8, dividing both sides by 2. Those 2's cancel out. 8 divided by, I kind of made a mistake here. 8 subtract 6 is not 8. That's 2. And then 2 divided by 2 is 1. So he gets an apricot weighs 1 ounce. So at the end of the day, his first goal was to determine the weights of the fruit that he had, and he got that strawberries equals 2 ounces, and he figured out that an apricot was 1 ounce. So that was goal number 1. And goal number 2, he feels pretty successful about, because he represented all of his physical actions of moving weights, strawberries, apricots. He could represent those actions with equations, and so the equations were the same thing as his actions. And a lot of times whenever you're doing math problems, you'll want to try to visualize things, actions, moving things around. Moving 3 apricots here, moving 3 apricots there. Represent that in equations. It helps understand what the equations are actually saying. Moving the strawberries and weights is very physical. It's a concrete action, right? Where equations are more abstract. But if you can relate those two together, it makes solving the abstract equations a lot easier. So I hope that helps a little bit. Guys, thanks for tuning in. And so that's all, folks. Stay safe, stay healthy.